All right, so we are going to continue with identity or neutral element in binary operations. So our central analysis is identity or neutral element. Now, to understand this element, we need to focus more on neutral, the word neutral, because neutral is that which has no effect. All right, so the identity of neutral element, whenever it is found in a certain set, is always unique, and whenever it combines with any element under any operation, it has no effect on it. All right, for instance, in addition operation, the identity element or neutral element there is 0. For instance, if we say 2 plus 0 will give us 2, 3 plus 0 will give us 3, 5 plus 0 will give us 5. You will notice that 0 has no effect so far addition operation is concerned. All right, so 0 now becomes a neutral or identity element on addition operation. Then in multiplication operation, the neutral or identity element is 1, because so far multiplication is concerned, 1 has no effect. 1 is neutral. For instance, if we say 2 times 1 is going to give us 2, 3 times 1 is going to give us 3, 4 times 1 is going to give us 4, 5 times 1 is going to give us 5. So you can see that in multiplication operation, 1 has no effect, so 1 is the neutral element. So whenever 1 is combined with any of the elements in multiplication operation, it has no effect. It doesn't affect the number in any way. It still remains the same value. All right, so I'm going to give our simple definition of neutral identity element. That whenever an identity element is combined with any element under a certain operation, the value is that element. It has no effect, and remember, it is commutative. I'm still going in my next subheading. I'm going to talk about some of the property like commutative property, associative property, and distributive property. All right, so that is it. So let's define it. Given a non-empty set, X, which is closed under a binary operation, asterisk. So if for all A in X, if for any element found in X, there exists another element E, which is also found in set X, which is a non-empty set, such that A operation E is equals to E operation A, which is equals to A. All right, meaning that this shows that they are commutative. Like the order of arrangement is not important. That even if you say A operation E is something as saying E operation A, that anyone can confess that the order is not important. But the main emphasis I'm trying to lay here is that whenever whatever you called a neutral element combined with any element, it will give you that element, meaning that the neutral element has no effect. So this can be reduced as A operation E equals to A. All right. So meaning that E is a neutral element, that it has no effect. E is what? Neutral, or what? Identity element. It has no effect on any other element under a certain what? Operation. All right, that's what makes it a neutral. Okay, so if E exists, it is always unique. If E exists, it is always unique. All right, it is always unique whenever it exists. Now the summary of the whole thing is that if S is defined by the element A, meaning that every element in X can be represented by A, then if there exists at all another element which is also E, which can also be found in X, such that so far that the operation the operation asterisk is defined upon the set, all right, such that if you both a, remember a is any element in X, and now we now assume if there exists another element which is in X, which is E, that is at some point a can be E, all right. Remember, A is just a general representation of any element in X, while E is a particular element in X. Note the difference. This is general representation of any element, while this one is a particular element. Suppose that X has 10 elements. For instance, we have X has A1, A2, A3, A4. Okay, let me just stop here, blah, 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 all the way to A10. All right. Now, supposing that, remember, all of this A is represented by A. Now, suppose there is another element, let me say A3, and that A3 is equals to E. That is a particular element of X is E. Now, this E, whenever you combine it with any of the element under the binary operation, it will give you the result of that element. That this E has no effect on any of the elements. So if this E actually exists in X, one is that it is always unique, meaning that it cannot exist differently. It cannot exist more than one element. It can only be one particular element. So that is it. So let me take an example. I, a binary operation, is defined on a set R of real numbers by, okay, binary operation, let me call it asterisk. All right, asterisk is defined on a set R of real numbers by X operation Y equals to X plus Y for all. Remember, this is a short form of for all X, Y, which are real numbers. Now, this might be my first example. My second one is a binary operation. I will use small triangle here. Is defined, binary operation small triangle is defined on a set R of real numbers by A operation B equals AB for all AB which also real number. Remember, I'm using this for all. I'm using this as what? For all. For all. This will be there exist. There what? Exist. Then this, I'll be using this as such that. Such that. So take note of that. All right. So now in the both question, in the both I and II, we are all to find the neutral element. The neutral element. Obviously, with the instance I've given you, neutral element on this should be 0. Because it is obvious that this binary operation is addition and this binary operation is multiplication, because AB is A times B. All right, so obviously we are going to get 0 here and we are going to get 1. I'm going to get 1 here. Yes, that is it. Okay, so let's get started. Solution. So the first question says that X operation Y equals X plus Y for all XY which are real numbers, meaning that XY represent any real numbers. Now, the way we're going to solve this is that so far it is neutral element or identity element. We are going to formulate two equations. Of course, there will be two equations here. One equation is coming from the definition of neutral or identity element, while the remaining equation is coming from the general what? Equation given in the question. All right, remember we are finding neutral element. So we can say, let E be in R. That is, let E, which is in R, be the neutral element. Be the neutral element. Now remember that that if E is an element of R, it simply means that in R you can find E, meaning that E is already in R. That is the identity element we assume is already in R. All right. So what's the definition of E? Then it means that definition of E for all X in R, all right, S combined with E must also give you X. We have already understood this, that if E is a neutral element, then whenever it's combined with any element in that set, it will give you that element, meaning that E has no effect on any element. So this will become, the definition of E will be our first equation. So therefore we have that X operation E equals to X equation 1. Then the second equation will come from the general equation, and we're going to use only X and E so that we can get a result we can compare. All right, so we're not going to use any other thing apart from this X and E. So from this guideline we can formulate another equation. X remain X, but in this case Y will be E. The reason why we do so is that so we can compare, because if you cannot find the same expression in the second equation, you can't compare the two. All right, so we need to compare the two so that we can get our result. So X remain X. So from the general equation, whenever two elements combine, it's going to be addition of the two. So if these two combine, from the general equation, it's going to be addition of the two, which is X plus E. This will become equation 2. So comparing equation 1 and 2, comparing equation 1 and 2, if we compare them, the same thing equals to this, the same thing equals to this. So you see the same thing equals to different things. So that means different things are equal. All right. So that means X is equals to X plus E. So therefore we have that X equals to X plus E. Remember, they are the same. All right. So in this case, we are making E the subject of a formula. So we remove X from both sides. So if we do that, we have X minus X equals X plus E minus X. So that X minus X is 0, X minus X here is 0. So we have 0 is equals to plus E. So therefore, our E is equals to 0. So you can see that the neutral element under addition operation is 0. So we can try the same in multiplication operation. All right. So this will be our I. Then our II, we have that from here we have that A operation B is equals to AB for all AB in what? I. All right. So the same way, so we can say let E in R be the what? Neutral element. So in that case, if E is the neutral element, then what's the definition of neutral element? Definition says that whenever I pick any element in R and combine it with E, it's going to give me that element. So if I choose A, the same. If I choose B, the same. So we have A operation E will be equals to what? A for all what? A in R. For all A in R, or for any element which is in R. So we're going to use this definition of neutral element for our first equation. So therefore we have that A operation E equals to A equation 1. Then we'll use the same value and formulate our equation 2 from the general equation. General equation say any two elements that combine is going to be the product of the two. Obviously, you know that the neutral element here must be 1, all right? Because we have already shown you initially that neutral element in multiplication is 1. So if we do that, we have that A operation E. Remember here, A remains A and B is now E. So it's going to be the product of the two, which is what? AE, which is A first times the second, AE. So this will become our equation 2. So in the end, we are left with comparing equation 1 and 2. Compare the two equations. If the same thing gives you a different result, then that different result is the same. So from here we have that A is equals to AE. So therefore we have that A is equals to AE. Make E the subject of the formula. A is multiplying E, so we can divide both sides by A. So we now have A over A is equals to AE over A. So that A cancel A here 1, A here 1. So we have 1 over 1, which is what? 1 equals to E, and therefore our E is 1. So you can use this to understand neutral identity element. And one thing you must know is that a neutral element, we have two equations. One from the definition of a neutral identity element, and the other one is from general definition of the equation, and that is by the way.